Hello, thanks for taking the time to watch our 101 style webinar highlighting the MOLYKOTE grease portfolio and the new High Performance Multiuse or HPM specification. During the presentation, we will highlight the functionality of a grease, the different types of components that are used in formulation, how these components affect performance, and the lubricant selection process, along with the details with the new HPM spec from NLGI. A quick introduction on today's speaker, William Fick. Will has a Bachelor of Science in Mechanical Engineering and serves as lubricants application engineer for DuPont on the MOLYKOTE team. Will brings his expertise and perspective for today's training from several years in engineering roles in both the industrial and automotive markets. He focuses on product research and development to aid in solving difficult problems faced by today's manufacturing customers. Without further ado, Will, please take it away.
Good afternoon. As Phil said, we're going to be talking about the High Performance Multiuse or HPM greases. First, I'd like to take an opportunity to talk about MOLYKOTE. We're a global company of 3 primary manufacturing facilities in Cooper River, South Carolina, Wiesbaden, Germany, and Chiba, Japan. We also have TS&D and tribology labs throughout the world, some full tribology labs in areas like Midland, Michigan, Wiesbaden, Germany, Utsunomiya, Japan, and Shanghai, China. I'd also like to highlight some of our capabilities. We have material property capabilities such as dropping point, low temperature torque, and many more. Application and product development, things such as screen printing, dip spinning, material performance, things like 4-ball wear and weld, coefficient of friction, image capturing for wear scar and other use cases. And for those capabilities that we're not capable of, we do work with external labs and have strong relationships with them to make sure that we can get the task done. So let's dive into lubricants. Functions of a lubricant. Most people think that lubricants are just used to reduce friction. That's not the case. They're also used to separate surfaces, reduce wear, carry heat away from the parts, transmit power, and even manage contamination. On to the lubricant selection process. The lubricant selection process can get very daunting. That's why we rely on our handy LETS acronym, which is load, environment, temperature, and speed. Load would be things like the load that's applied to the part directly. Environment encompasses everything around the lubricant. So this would be material properties for the substrate it's applied to, and things like salt, sand, any type of contaminants. And then temperature, you would look at the actual temperature that the grease might be susceptible to, or whatever lubricant that you're using. And then you have the speed, which is the relative movement of those parts that are being lubricated. Some prime examples of that would be things like a press fit application, which typically be a slow speed, high load application. Bearings, typically moderate to fast speeds, although they can be slow. That's why it's very important to look at these 4 things when you're looking at what type of lubricant you need. Really, all of them play a critical role, and there's millions of lubricants out there. It's important to get as much information as possible. For those of you not familiar with MOLYKOTE, we do have quite an extensive product range. We have 550 products, 6 different product groups. Those groups include greases, pastes, oils, compounds, dispersions, and anti-friction coatings. All of these are used for different cases. As you can see on the left, we have tribology is a science of friction and wear between moving surfaces. Well, when you're looking at what type of friction, it can really be broken down into 3 separate categories. Boundary friction, which would be a surface-to-surface type of contact. Hydrodynamic friction, which would be where you're keeping the 2 surfaces from contacting one another. And then you have mixed friction, where you have some asperity friction, but primarily you have that hydrodynamic friction where you're keeping the 2 surfaces from contacting. Each one of these cases kind of relies on a different type of lubricant. You can see boundary friction, we typically would recommend pastes or AFCs. Mixed friction, usually greases with solids to handle those brief moments of contact, or dispersions. And then for hydrodynamic friction, we use greases, fluids, and oils. So we're going to be focusing on greases. So let's talk a little bit about what a grease is. A grease is composed of base oils, which are 65 to 90% of the composition. And the primary reason for having a base oil is to lubricate. Your base oil is doing most of your lubrication for a grease. Thickeners are 10 to 30%, and they're in charge of really holding that base oil in place so that it remains wherever it's applied and keeps doing lubrication it needs to. Additives, 0 to 10%, so they're not always present, but they are added to really just attack a more specialized application. So looking at a grease and breaking it down to all the possible combinations that you can have, it can get really intense. For base oils, you can really break it down into three main categories. You have your mineral oils, synthetic oils, and vegetable oils. For thickeners, you have soaps and non-soaps, and then within that, you have simple, complex, inorganic, and organic, and many different options within these as well. Two of the more common ones that you'll see might be lithium or lithium complex. And then going down to additives, you have things like oxidation inhibitors, EP additives, anything really to tackle a specific application where improvements might be needed. And the same kind of goes for adding solid lubricants. They have their specific use cases as well. It's worth pointing out that there really are millions of possible different combinations, and that's why you have so many different types of greases out there. So there's no real one size fits all, but it is nice when a grease can handle more. Let's look a little more at base oils. We'll compare mineral oils to synthetic oils. When it comes to synthetic oils, you really get a more narrow molecular mass distribution. And along with this mass distribution being more narrow, you get enhanced properties. You would get things like a wider temperature range, better compatibility with plastics and elastomers. You even get a better viscosity and temperature curve, so you'd get a more consistent viscosity over a wider range of temperatures. You also get the superior chemical and oxidation resistance and a lower evaporation rate. There's inherently nothing wrong with mineral oils. You just get an added benefit from going to something like a synthetic in most cases. This slide does a really good job kind of showing why that is. So on the left side, you can see the molecular structure of mineral oil, or the few different molecular structures. So you can see that there's no consistency really. You have a wider range of lengths and sizes versus on the right side where you can see a synthetic oil, which is a polyalpha olefin or a PAO. Every one of those are the same. And due to this, you get a more consistent viscosity, because let me try and explain this in something that you might understand better. Have you ever tried rolling something heavy like a piece of furniture on logs or pipes, and you keep moving that back pipe to the front? Well, that makes moving something really easy. But now let's say every pipe in there is a different size or a different diameter, maybe slightly misshaped. It's going to make moving everything a lot more difficult. And it's kind of the same understanding here. You'll get increased friction as you're moving things because the inconsistencies. So I'm going to take a minute to talk about NLGI. That's the National Lubricating Grease Institute. They're a not-for-profit trade organization with over 400 members. These members include marketers, manufacturers, suppliers, and technical specialists. Pretty wide range of different people. They do have a global presence. Part of what they do is they fund lubricating grease research, promote different laboratory and field tests, and they also provide different educational opportunities, things like training videos or classes on how to perform specific tests. And for anybody that's familiar with the GCLB certification in the automotive industry, NLGI was in charge of creating that specification. Also going to note that DuPont is a member and actually involved in NLGI leadership. And the reason that I wanted to bring up NLGI is because we're going to talk about the HPM Grease certification, and they're actually the creators of that certification. The HPM certification was actually written by about 30 global grease technology leaders. These leaders include both automotive and industrial manufacturing end users. So this truly is certification that was written and created by the actual customer. So it is the voice of the customer, and it was created to meet a need. Let's get into it a little bit here. There is 4 HPM spec, and then there's also 5 enhancements to that spec, as you can see in the graphic on the right hand side. So at the top we have our High Performance Multiuse or HPM Grease specification, and then we have additional luggage tags, which are pluses. As you can see, HPM plus WR represents plus enhanced water resistance. We have plus HL, which is plus enhanced high load carrying capacity, plus LT, which is for enhanced low temperature performance, plus CR for enhanced saltwater corrosion resistance, plus LL for enhanced long life. It's also important to note that MOLYKOTE was involved in the development of this HPM spec from the starting point to the finishing point. So let's talk about some reasons why HPM Grease certification is needed. Really, in the industrial market, there is no real guideline. So this new HPM spec kind of serves as a guideline of how an industrial grease should perform, and it should help simplify the grease selection process. For example, if a process requires an HPM certified grease, now you can just go to any HPM certified grease and just take it right off the shelf, You don't need to go through a bunch of testing and things like that. It should just work because it meets that spec. It also kind of puts criteria behind that description of multi-use high performing. So someone can't say, yeah, this is a high performing grease, and then you look at it and say, well, this isn't HPM certified. So it kind of puts a basic ruling behind what that actually is. An overview of the specification. As I said before, there is the core specification, which includes 14 ASTM test methods. And then for the enhanced water resistance, it would be an additional 3 ASTM test methods. In case I didn't make that clear, the core spec needs to be met in order to get these enhancements. You can't have an enhancement without first passing all of the 14 ASTM core spec methods. So moving on to high load carrying capacity, you would need an additional 5 ASTM test methods that are focused towards load carrying. For low temp, there was an ASTM method, a US steel method, and one DIN method, again, focused towards low temperature. Enhanced saltwater corrosion resistance, 3 ASTM test methods, and then for the long life, that method's not quite established yet. It's still in the works, but we're expecting that to come out sometime in the near future. So I'm not going to go through each of these because that would be pretty boring, but it's here for me to show you the magnitude of the tests that need to be passed in order to get this core certification. It does include things like penetration and roll stability, which are truly there to show that this grease is going to be a shear stable grease if it passes this test. Also things like water washout characteristics, so it doesn't easily just get swept away by water. Your typical corrosion testing to show that it can withstand corrosion. So really this spec is covering all the bases to ensure you that you're getting a well-rounded product. And I want to also mention that this is not an easy spec to meet. You can't just pull a grease off the shelf and expect it to pass this because it's not going to happen. Moving on to the enhanced water resistance, as you can see, adding that plus WR in these 3 test methods, they get much more stringent than you would see on that original core spec. Some of them may be similar tests, but they get way more difficult to pass and ensure you that you're getting a product that's going to really help out in those applications where water resistance is needed. For plus CR, which is your enhanced saltwater corrosion resistance, again, just a few tests, but it really kind of solidifies that you're going to be getting that additional corrosion resistance that you need for that specific application. Enhanced low temperature performance, even if some of these tests are duplicates from the original, again, they get more difficult. Things like stepping the requirements down and making the test conditions much more difficult. And then last, we have the high load carrying capacity, which is 5 tests, but it's really going to ensure that you're getting that additional wear and load protection, keeping your parts from welding together or whatever you need. Let's look and see what the benefits of HPM Grease certification is. Really what it's doing is it's providing you with that standard for high performing greases and what they should be. It provides you with those additional luggage tags, which if you have a specialized application, you know is going to be difficult in some area. You know you're getting a well-rounded grease in addition to also having something that is going to excel extremely well in that area. For example, if I want something that I know is going to be in a very cold environment, not only am I going to get a plus LT, which ensures that I get great low performance benefits, but I'm also going to get a very well-rounded product in addition to that, which is nice. You're also going to get a reliable and consistent grease because if it's HPM certified, you know what you're getting. It also helps ease in that grease selection process because if people start really saying like this needs to be HPM grease certified, or if you're just trying to do any type of basic lubricating, it's going to do really well for 70% of applications that are out there. Really, it's just going to be a grease that's also capable of addressing a large breadth of applications. But in addition to this, I'd like to note that it's not a one size fits all. Like I said earlier, there's no one size fits all. For certain applications that are more specialized, there are application engineers out there that are willing to help, and it's always worth it to get a second opinion if you have one of those specialized applications. Finally, I'd like to talk about MOLYKOTE's offering for HPM certified greases. I'm happy to present you with this HPM Plus LT. The MOLYKOTE Multilub synthetic high performance grease is a grease that's going to perform well at low temperatures in addition to many other areas. It boasts a bright yellow color. What this yellow color can do for you is make it more easily distinguishable on shop floors or out in the field. Makes it so you're not getting it mixed up with whatever other greases you might have out there. It also has this wide service temperature, and due to the LT that it has, it also has a wider temperature than most other HPM certified greases out there at the moment. It also has a high load carrying capacity, which is great and helps it cover even more applications, as well as has low coefficient of friction, which can make for more efficient designs and smoother running of machinery. You also have the compatibility with many plastics and elastomers, which is great. It allows it to be applied to more applications and really can help you with making more lightweight choices. And then again, it's got that low temperature tag, so you would expect exceptional low temperature performance. And it's really suited for so many applications, things like bearings, gears, slides, gearboxes, spindles, agitators, actuators, pretty much anything that you can think of, it's probably going to fare pretty well. That's what we have for our offerings for MOLYKOTE for HPM certified grease. And thank you.
Perfect. Thanks, Will. Thank you for watching the video. If you have any questions or concerns, feel free to reach out at molykote.com or lubricantspecialty.com.